Trig Review Test 3, Problems 13 and 14. Number 13, find the exact value by using a difference identity for the tangent of 285 degrees. Now it says using a difference identity, but I am not going to hold you to that. I would use a sum or difference identity, whichever of these two identities you want to use. You'll get the exact same answer, either one. It's just that if you use this one, you think of two angles that add to give you 285. If you use this one, you think of two angles that subtract to give you 285. Well, 240 and 45 are the two angles that spring to my mind, so I'm going to use this first identity. The tangent of 240 degrees plus 45 degrees. Remember, we always have to use angles that we can find the exact value of. You write down your identity. You know that the tangent of alpha plus beta is the tangent of alpha plus tangent of beta all over 1 minus tangent of alpha times the tangent of beta. So, if I substitute my values for alpha and beta into this, I have the tangent of 240 degrees plus the tangent of 45 degrees all over 1 minus the tangent of 240 degrees times the tangent of 45. The reason that I just really kind of like using the exact value chart is that it's easy to look across there and find my values for tangent. 240 degrees has a terminal side in the third quadrant. We'll have a related angle of 60 degrees. I look across here, the tangent of 60 is the square root of 3. In the third quadrant, that will be positive because down here x is negative and so is y. So the tangent of 240 is the square root of 3. The tangent of 45 is 1. In the denominator, I have 1 minus the square root of 3 times 1. So I have the square root of 3 plus 1 and 1 minus the square root of 3. I'm going to rewrite that numerator as 1 plus the square root of 3. So I got 1 plus the square root of 3 over 1 minus the square root of 3. All is good, except you know you cannot leave the square root symbol in the denominator. Multiply by the conjugate. That means I have to multiply the denominator by 1 plus the square root of 3. Same thing in the numerator. Denominator is 1 minus the square root of 9, which is 1 minus 3. Denominator is negative 2. Numerator is 1 times 1 is 1. Outer times outer is the square root of 3. Inner times inner is the square root of 3. So I have plus 2 times the square root of 3. You know the square root of 3 times the square root of 3 is 3. So that I now have 4 plus 2 times the square root of 3 all over negative 2. Factor out a negative 2 out of the numerator. That changes that to negative 2 minus the square root of 3. The negative 2 that you factored out of the numerator cancels with that one in the denominator. Final answer, negative 2 minus the square root of 3. Number 14. find the tangent of 13 pi over 12. The first thing I want to do is change 13 pi over 12 so I can think about this a little better. 180 over pi. You do that simplification, and you're going to come out with 195 degrees. If I want to find the tangent of 195 degrees, I'm looking for two angles that add to 195 that I can find the exact value of. Well, I know the tangent of 45 is 1. If I subtract 45 from 195, I've got 150. I can find the tangent of 150 because it has a related angle that I can find the tangent of. So I'm rewriting this as the tangent of 150 degrees plus 45 degrees. We're using that same identity we used in problem 12. This is my alpha, this is my beta. I have the tangent of 150 plus the tangent of 45 over 1 minus the tangent of 150 times the tangent of 45. Substitute the values in there for those angles. 150 degrees has terminal side in the second quadrant. Theta prime equals 30 degrees. The tangent of 30 degrees is the square root of 3 over 3. In the second quadrant, it is negative because x is negative and y is positive. So I have negative square root of 3 over 3 plus 1 over 1 minus negative square root of 3 over 3 times 1. I'm going to rewrite my numerator as 1 minus the square root of 3 over 3. My denominator is 1 plus the square root of 3 over 3. I'm going to simplify the numerator and denominator separately. If I want to combine these two terms, that one can be rewritten as 3 over 3. So this is 3 over 3. I've done that so that I can add it to my other term that I have in the numerator. So I have 3 minus the square root of 3 over 3 in the numerator. In the denominator, I'm rewriting this 1 as 3 over 3 so that my denominator becomes 3 plus the square root of 3 over 3. These 3's cancel. If you need to know why, and let's go right up here and let me show you. If you had 3 minus the square root of 3 over 3 divided by this, you would invert and multiply. It'd be times 3 over 3 plus the square root of 3. So these are gone. I have 3 minus the square root of 3 over 3 plus the square root of 3 multiplied by the conjugate of the denominator, which is 3 minus the square root of 3. Whatever you do to the bottom, do to the top. This denominator becomes 9 minus 3, which is 6. The numerator is 9 minus 6 times the square root of 3 plus 3, which is 12, minus 6 times the square root of 3 all over 6. Take a 6 out of the top. You have 6 times 2 minus the square root of 3. The 6 is canceled. You got 2 minus the square root of 3. Final answer. I'll leave that there for you just a minute so you can look at it.